All right, I have an example problem here, and we have to deal with two dimensions of this. So I have a 20 kilogram sign being held at rest by two cables, and I want an attention to each cable. So I'm going to label this T1 here, I'm going to label this T2. And my free body diagram is going to be those two forces, and the force of gravity going down here. Okay. Now, the physics behind this is this. Since it's at rest, forces cancel. So I can say my x forces cancel. My y forces cancel. So let's split these into their x and y components. So I'm going to draw these in here. This will be T1x, T1y, T2x, T2y. Now, my x forces cancel. My only x forces are this T1x and this T2x. So T1x and T2x. My y forces cancel. I have three. I have the force of gravity down, and I have T1y and T2y both pulling up. So I know that the up forces, T1y plus T2y, have to cancel the force of gravity going down. That's really the physics behind it. After that, it just becomes kind of a trig and algebra problem. So, first off, we have to get expressions for T1x and T1y. So T1x is going to equal, now I'm not going to get a number for it, but I know I have this 40-degree angle. T1x is the adjacent side, so I'm going to use cosine. So T1x is going to be T1 cosine 40. And if I plug in the cosine of 40 in my calculator, I end up with T1x equal 0.766 T1. And T1y equal T1 sine 40. So T1y is going to equal 0.643 T1. Do the same thing with the y. T2x is going to equal T2 cosine of 60. So T2x is going to be 0.5 T2. And T2y is going to be T2 sine 60. So T2y is going to be 0.866 T2. Now the only other thing is I have to get a value for the force of gravity. So I do Fg equals mg into 20 times 10 is 200. Now I can go back to my forces canceling equation, and in T1x equals T2x, T1x is 0.766 T1, T2x is 0.5 T2. And then for my y forces cancel, I get T1y plus T2y. So T1y is 0.643 T1 plus T2y is 0.866 T2. And that has to equal the force of gravity, which is 200. So now I have an x equation and I have a y equation. So I have two equations, two unknowns. I'm going to simplify substitution. So if I divide both sides over here by 0.766, I get T1 is 0.5 T2 over 0.766. That gives me T1 equals 0.653 T2. Then I'm going to take and plug that in over here for T1. And I get 0.643 T1. Oops, sorry. 0.643 times my T1, which over here is 0.653 T2 plus 0.866 T2 equals 200. Now if I multiply this out and add it together, I get 1.29 T2 equals 200. And then divide, and I end up with T2 is equal to about 155 joules. Then I'm going to take that and plug that back in over here, and I get T1 is 0.653 times my value for T2, 155, and I get T1 is equal to 101. So if you have x and y, you have to split your forces up into x